All right, so let's study about probability. Simply, probability is just we study about chance. So it's the study of chance. A lot of time you talk to your friends and you're asking, hey, what's the chance it's gonna rain today? The weather, that's what the weather forecast people are concerned about, the chance, but another way of saying that, it's the probability of raining. And then what's the chance of getting a good grade out of the class and all that. So in formal term, it's probability. We will be studying probability here in this video lesson through a whole series of different examples, and we're gonna pick up terminologies as far as concepts throughout different examples here. And before we advance any further, I gotta make clear that the entire intention of this video lesson is to aim as giving you enough probability understanding to operate and be comfortable with bringing that into statistics work. But we don't have to learn it in that much in depth as compared to the formal probability courses. All right, so here we are at our example 1 here, our first example. And so the example here start out with simply we're rolling a regular 6-sided die here. And the first question regarding this, what are the outcomes? And so before we rush into getting an answer, all I need to clarify here, a lot of, and actually not only a lot of time, but anytime you are doing a probability, you always need to have a, you see, look at rolling a regular 6-sided die here. We regard to that as an experiment. So we always, anytime that we run a probability problem, there has to be, or there must have been some kind of experiment that generates outcomes. Okay, and so now we imagine the situation now is that we're rolling a regular 6-sided die, and so what are the outcomes that turn out? And so the outcomes now, the answers everybody can easily have in mind now is that those are the numbers 1, 2, 3, 4, 5, and 6. So these are the number on each individual side of your 6-sided die. And traditionally we put all of these outcomes because in the end all of these outcomes they form a set of values. And so traditionally we use curly braces as to indicate this is a set of outcomes. This set of outcomes right here, in formal probability term, we refer to this as a sample space. And sample space, a lot of time throughout my lecture here in this video, I use the term SS right here to be short for sample space. It's just simply something that saved me time writing. All right, and so same example 1, but now we are ready for question number part B. So here I'm gonna start wording question part B right here. So after rolling a regular 6-sided die, and we've learned previously that this is an experiment, and it generates for us 6 outcomes totally in our sample space. And so what is the probability of getting, let's say, a 3, the number 3. And so anyone who viewed this video here will instantly pull up an answer. That answer there for this question, what is the probability of getting a 3? The answer there is simply 1 out of 6. All right, I agree. We all know the answer is 1 out of 6, but let's not stop the question here. The whole intention I brought up this question, it has a lot of understanding to be brought out here for us, and once we really clear with all that ideas, and I'm going to move on to the next question. So just as I said earlier, the term probability here is, if it's too formal for anyone, then what is the probability simply means the same as what is the chance. So here we roll a regular 6-sided die, and so we're asking ourselves what is the chance of getting a 3, the outcome being 3 right here. And so there are a lot to see in this in the way how this question is wording. So I need to introduce for everybody a way of using symbolic statements here. The exact same worded question here, and I'm not talking about the final answer at all here. I'm talking about a symbolic representation of the same question here, so that later on when the problem gets longer, then using a symbolic statement is going to be a lot more convenient. But so here, right now, it's really just throughout in this lecture, it's just our first question anyway, so you probably don't see much. But later on, as we keep going through and I'm keep putting up the other questions, any question is always starting out with just what is the probability, and what is the probability of this, and what is the probability of that, or what is the chance of this happening, what is the chance of that happening. And so what is the probability? We can just use a formal symbol, a capital letter P. So capital letter P with an empty pair of parentheses. That is a symbolic statement of indicating we are looking for the probability. What is the probability? Or find the probability. And then what goes inside here? So now I have to underline this. Back to the worded questions, right after that famous phrase, what is the probability of? Then there's some indication here that this is indicating what we're looking for, really. So we're looking for getting a 3, a number 3, the outcome being 3. And so I underline this in red. The formal term for this is called an event. So an event is basically like a requirement. It's something that your probability question is looking for. Or if it's really our word here, then the event is what we are looking for, the requirements that we're looking for, a category that we're looking for. And so in formal probability term, it's called an event. And so back to this, the way how we're constructing our symbolic statements. And like I said, again, we're done with the answer. I'm just simply showing you how we can go from the worded statement into a symbolic statement here, so that it can bring a much better convenience later on as I keep bringing up more and more probability question. And I highly recommend that everybody, after viewing this video lecture of mine, mainly get comfortable with using the symbolic statement like this. So once again, in short, my question here is the worded way. What is the probability of? So that is capital P in parentheses. My event there, I'm gonna throw that event in here simply, and doesn't have to be too fancy. It's just something nice and short and simple, but descriptive enough. So getting a 3. So all that events there being put in here. This complete statement, admittedly, is a lot shorter than the worded statement, but it tells you all that questions. The question here is looking for find the probability of getting a 3, and now the answer there, that's why I put the equal sign, equals 1/6. And so here we can successfully put the answer here. And so, and yes, once again, we call this is the answer, but so why 1/6? Why 1/6? So 1/6 as a fraction. So if you make a connection, or maybe you can rewind the video here, but if you look back into question A that we've had earlier, then the 6 in the denominator here, really it's not the last outcome of your entire sample space, but the 6 here represents the number, or the total number of outcomes in the sample space. And that's what the 6 in the denominator is for. And the number 1 here in the numerator is indeed the way how I explain it. Usually this is the number of outcomes that meet the events. And as I was explaining earlier, it's perfectly just fine to understand an event as a requirement. So what I'm trying to explain here is that this number 1 right here in my numerator of the answer is to represent the number of outcomes that meets the event, or another way of thinking, meets the requirement. And so, and that's the way it is. So anytime you find the answer to a probability question, all you do is just find the number of outcomes that meets the event and over the total number of outcomes in the sample space. And so right after seeing how we obtain that answer from question B of example 1, then allow me to take things off direction just slightly a little bit. But so generally for any time later on as we are doing probability, I'm going to say a lot of times symbolically I'm going to be using a capital letter E to represent an event. So let capital E be an event. And so we can find a generalization of how we can find any probability. The probability of any event, and that's what the capital P in parentheses, I put in that capital E in there. So probability of any event is simply equals to the number of outcomes that meet the event, and we're putting that as a fraction over the total number of outcomes in the sample space. And welcome to the world of probability, ladies and gentlemen. You have found the most fundamental and the only important formula in probability. It looks surprisingly simple, but there are PhDs who spend their lifetime to find the right way to count the number of outcomes that meet the event over the total number of outcomes in the sample space. Well, of course, I'm not going to expect anyone in my course here to be that far detailed and to become an expert in probability, but once again, you're never going to look down on this formula. And so now let's look at the next question in the exact same example. And you can see that I purposely leave that starting phrase of my question here. What is the probability of, and here I'm getting ready for my question C. So what about, what is the probability of getting a number? All right, and so this time, as soon as I put up the question, I really need everybody to hold on to your own answer in your own mind right here. All I need here is just too slow, and I apologize that I have to slow down any one of you. But the point here is let's learn and let's get fluent with setting up the symbolic statement right out of a worded question like this. All I need right now is to aim at setting up the symbolic question that's equivalent to this lengthy worded question. And so the second question already, and still having the exact same phrase, what is the probability of getting a number? And so here's your event. Event here, and another thing that I highly recommend, anytime that you're working on a probability question, being able to nail down your event successfully is a big plus. And so back to the question again, worded statement, what is the probability of? So here's my empty pair of parentheses with a capital P in front. Find the probability of what I'm looking for, the requirements I'm looking for here. I'm simply looking for getting a number. And that's all it needs. We simply put the events here. So that's how we successfully set up our symbolic question right here. And like I said, I highly recommend that gets comfortable with how we're setting it up, or at least understands what a symbolic question like this is asking. And so now here we go, let's find the answer. So now the answer here, that's why I put the equal signs. How big is the sample space? Again, we have a total of 6 outcomes in the sample space. And so now, of course, anytime, so the event here, the requirements here is just simply looking for a number. When you roll that die, we look for a number, a number, any number. And so, of course, when you roll a die, you're going to get a number. So the chance is going to be 6 out of 6, because any of those outcomes you get is a number. And so And so now this is going to be 1. And so that is our final answer. But once again, I highly recommend that starting with this question right here, stay as close as you can with the formula I wrote down a little earlier. And so this number 6 on the numerator is indicating the number of outcomes that meet our event. This number in the denominator represents the total number of outcomes in the sample space. And then of course, so now some math works out here and reduce it down to 1. So that's our final answer here. And now let's look at another question. Here I call it question D right here. And exact same question. I'm looking for what is the probability of, here the requirements we're looking for is getting about an 8. And once again, whoever is already having an answer in mind, hold it to your own thoughts right here, because all I need right now, and once again I apologize for slowing down anybody, but all I need here is to successfully set up the symbolic question of this. Because here what you have is only a worded question, but a lot of time later on we need to be able to understand the symbolic statement of that. So what is the probability of, so all that famous phrase there now is a P in parentheses. And now the next thing we're going to recognize our event. So in here, right here in our question, the event is being underlined right here. Getting an 8. And so I need an 8, so getting an 8. So that's our event, our requirement. So now this symbolic question here is only the questions in symbolic expression. And now here we're going to start looking for the answer. So that answer now, the answer to the question is, in my whole sample space, there are 6 outcomes totally. 6 outcomes total in my sample space. But now, how many of those outcomes meet our event here, meet our requirement? Our requirement here, we're looking for a number 8. But none of those is being an 8. So we found 0 outcomes right there. And so once again, I purposely walk through the steps right here so you can see that we always need to nail down and solidly nail down. We need to have number of outcomes meet our event over the total number of outcomes in the sample space. And so in that way, mathematically it reduces down to 0. All right, and once again, allow me to take things a little bit off direction again, and we'll be back to what we were doing. But so we found earlier, we generalized earlier that anytime capital E be an event, then the probability of E, the event, simply found by finding the number of outcomes that meet the event over the total number of outcomes in the sample space. But then, if we look through all of the answers we've arrived at throughout question B all the way up to D right here in our just finished example, then here we can actually find another regulation. And of course, you can pause the video or even rewind the video anytime to go back to each question and how we developed the answers. But now what we found here is that anytime you're finding the probability of an event, then you see question in B gave us an answer 1/6. And 1/6, scratch work right here, 1/6 in decimals is a 0.1666 and a lot longer. But in the end, my point is it should be less than 1. And so, and yes, it would be the same for any other problem. Anytime that we doing probability, the answer would be less than 1. And of course, we will never have negative probability. So it makes sense to put another low end on my interval values here for probability. So probability only happens anywhere between 0 and 1. But then as you looked into question C, it gave us the answer being 1. And so we realized that probability can be as high as 1, indicating something that will absolutely happen. Like say, hey, if the weather forecast person is telling you that the chance of rain today is 100%, he's telling us that absolutely it will rain. And so when 100% chance happen, that is equals to a different way of saying that probability equals 1. So probability can only be as high as 1. And then in question D, we realized probability can also be as low as 0, indicating something that will absolutely, something that absolutely won't happen. And so this is another strict understanding that you should always double check that, because a lot of time when you do a probability calculation, it's easy to follow along with the calculation and forget our goal, and sometimes we run into error that we have a probability being a 1.5. That is when you gotta go back to check your answer.